Welcome to this Tableau tutorial where I'm going to show you how to create a dot distribution map. Dot distribution maps are useful for visually displaying clusters of data which have a geographical element. In this example from Tableau, each dot represents one instance of a hailstorm in the USA over several decades. The clustering of the dots shows obvious weather patterns over time. The data I will be using today is geographical locations of air crashes from 1980 to 2009, which had fatalities of 100 or more. A dot distribution map will enable us to see all of the final destination points of these crashes, and to identify if there are any spatial patterns within the data, as there were in the hailstorm example. This is what the spreadsheet looks like in numbers. I have the name of the city or town in this column, and the correlating latitude and longitude coordinates in separate columns. This geocoding will enable Tableau to pinpoint the individual locations of each of the air crashes and represent them with dots. I've also included an additional variable, crash cause, which I will be using to show you a way to customize your map. I'm using numbers on my Mac, so I've saved this file in Excel format so that it can be imported and read by Tableau. Click into the Data Source tab if you're not automatically taken there. Tableau has recognized the two coordinates columns in my data as having geographical roles. If Tableau doesn't do this for your data, you can do this manually by clicking the top left corner of the column header and choosing Geographical Role in the drop-down menu. Then select Latitude or Longitude. My crash cause column is categorized as text, and this is perfect for what we're going to be doing later. So now we're ready to open the worksheet. My lats and longs are listed under Measures. I'm going to click and drag my longs to columns and my lats to rows. To populate those dots, we need to change the longs to dimension in the drop-down menu. And here we have our map. So here are our final destinations. At this point, the map isn't telling much of a story about these air crash incidents. There isn't a very obvious phenomenon occurring here. This is one of the disadvantages of a dot distribution map. Sometimes there is no phenomenon that has taken place that can be visually captured in this way. Here we are working with a pretty small dataset of only about 85 incidents. A large dataset could produce a more telling visualization, such as the hailstorm visualization that we saw earlier. So we're going to explore the variable of crash cause using colour to see if that will tell us anything more. I'm going to drag my cause of crash dimension into the colour mark. Some crash causes, like crew error, are pretty consistent across the regions. But there are a couple of patterns that stand out. In this part of the map, there's a higher concentration of red dots representing catastrophic aircraft failure. This leads me to question which companies manufactured the aircrafts and who were their airline operators. Maybe there's a connection to be found through further research. In Southeast Asia, there's a small cluster of yellow dots representing sabotage. I'm now interested in investigating what's behind these events. What factors have contributed to the formation of this cluster, or is it completely random? So this is why adding a variable is important. It told us some things, but it also led to some questions. So that's it. I hope you found this video helpful and that you feel confident in making your own dot distribution map. Thanks for watching.